Okay, so now we'll do question number 14. What is the Lewis structure of this tri-sulfur atom or compound? So first, let's find the total number of valence electrons. So each sulfur atom contains 6 valence electrons, and we just have the 3 that are bonded together. So we have a total of 18. So let's say we had all of our sulfurs with a single bond in between each one. So none of these have a full octet yet. So let's see what happens if there is full octet. So one of these will have a double bond. And let's count out how many electrons I've drawn. So we have 1, 2, 3, 4, 5, 6. Each bond contains 2 bonding electrons. And we have our 18. But now let's calculate the formal charge for each of our sulfur atoms. Since they all have different bonds and they all have different number of valence electrons, let's calculate the formal bond of our single bonded sulfur first. So the first one. Well, first I should show the equation for formal charge, which is the number of valence electrons minus the number of non-bonding electrons. So these are all the number of lone pairs minus the number of bonding electrons divided by 2. Okay, so now let's try to find the formal charge of the single bonded sulfur on the left. There are 6 valence electrons. There are also 6 non-bonding electrons. And there's only the one bond, so we have 2 bonded electrons divided by 2. So this sulfur has a negative charge. So I'm just going to draw a negative sign. And now let's calculate the formal charge of the middle sulfur atom. There are still 6 valence electrons. This time there are only 2 non-bonding electrons. And there is a total of 3 bonds, so we have 6 bonding electrons divided by 2. So 6 minus 2 minus 3 is positive 1. So this sulfur has a positive charge. And now let's find the formal charge of our double bonded sulfur. So there are 6 valence electrons. There are 4 non-bonding electrons. And there are also 4 bonding electrons divided by 2. So our last sulfur has a formal charge of 0, which is good, since we have an overall neutral compound. So we can also draw the resonance structure, just showing how that negative charge can be on the rightmost oxygen as well. Okay, so these are the 2 resonance structures for this tri-sulfur compound. And the junior tutor said you first need to determine number of valence electrons, which is 18. By obeying the rule of octet and by distributing the total number of valence electrons around the corresponding atom, we'll have the following Lewis structure for the compound. Okay, so they show the 2 resonance structures. To check, we can count for the total number of valence electrons using the dots from the illustration above, and we still have a value of 18. Okay, so this solution is